Okay, Assalamualaikum and very good morning to all. Okay, so today we will continue our next lecture, okay, which is on the pneumatic and hydraulic actuator system. Okay, so informed before, okay, so I already put the slides, okay, so that you can go to the what is the on the overview of this pneumatic and hydraulic actuator system. Okay, so basically there will be four parts of this chapter. Okay, so this is part one on the overview of this both system. Okay, so the next one is actually I want to take a little bit time to update you on this revised schedule. Okay, so basically previously Dr. Elmi in charge on the first half, but somehow I need to replace his slot. Okay, so that I will teach you on this first half until the week 7. Okay, together with Dr. Zahurin lah on his part. Okay, so just to update. Okay, for today basically we should cover on the part 1. Okay, on Friday hydraulic and pneumatic actuator. Okay, part 1. Okay, so basically on previous two class you already complete on the introduction of mechatronics part 1 and part 2. So the assignment have already been given, so just remember the deadline on the 30th of October. Okay, so for the next weeks, okay, they will be on the part 2. Okay, we'll cover on the Monday and Friday. So basically they will be on only one videos for each part, but you can that is cover for both days lah. Okay, same goes to weeks 4. Okay, they will be part 3 and finally part 4 in week 5. Okay, so after that we have a remaining 2 weeks before we go into the midterm breaks. Okay, so basically in week 7 I will introduce you some of simulation methods, okay, using hydraulic and pneumatic actuator system. Okay, so from this you will be given a task on the group simulations. Okay, and finally in week 7, hopefully by Monday or Friday we will have a test on my part. Okay, this is online test. Okay, so for this chapter there's a on the cover of CO5. Okay, as briefed by Prof. Zahurin before this. Okay, so at end of this chapter you should be able to firstly is to identify the common pneumatic and hydraulic component symbols. Okay, so basically in terms of graphical it can translate into a symbolic diagram, so you should know what's kind of symbol that refer to pneumatic and what kind of symbol that refer to the hydraulics. Okay, of course, the second one is you're able to design pneumatic and hydraulic circuits using the various actuator and control elements. Okay, so basically after introduce you on the simulation method, you should be able to design both system in that software. Okay, so for the outlines today, okay, the first one is on the actuation system in overall. Second one, 2.2, is on the pneumatic and hydraulic system. There we go through the detailed one on the what is hydraulic system and also what is the pneumatic system. Okay, and also valves, okay, that involved for both system. Okay, so let's go to the actuation system first. Okay, so basically actuation system is element of control system, okay, which are responsible for transforming the output of the microprocessor or control system into a controlling action on the machine or device. Okay, so before this in my previous slide we already learned on the overall system like closed loop system or mechatronics. So actuator is one of the elements that give a like a counter measurement on the closed loop. Okay, because we have measured like sensor for everything, like maybe we have a force sensor to measure some of the range of the forces, and then maybe we need actuator like hydraulic or pneumatic actuator to give the counter signal, okay, maybe to move the robots, okay, or maybe to move the door, okay, for example, or maybe to counter the vibration, okay, to reduce the vibration, maybe we need to put the actuator. So basically it's transform anything, the information from the control, okay, like we have a displacement of 5 cm, and then your controller feedback that okay, we need to counter this vibration by minus 5 cm. So the minus 5 cm that produced by the microcontroller signals is sent to the actuator system, okay, so that it can transform in a practical movement instead of just a control signal into a voltage or everything. Okay, so this topic will discuss two fluid power systems, which is pneumatic and hydraulic. So basically pneumatics, okay, what is pneumatic is actually actuating fluid is compressed by air, okay, it's a use of elements. And hydraulic is the actuating, the movement is from the from the uh, oil, okay, the direction of the oil to move the actuator system, okay. Okay, so this is on the pneumatic and hydraulic system, okay. Okay, so basically pneumatic signal, okay, we go first on the pneumatic signal are often used to control final control elements, even when the control system is otherwise electrical. Okay, so this is some kind of the pneumatic actuator and their detailed valve and control elements, okay. So that's basically, if we have the what I have said before, if we have a control signal, okay, this maybe come from the electrical signal such as the voltage or amp from the microprocessor and microcontroller, so it's transformed to the this mechanical system lah, okay. So that's it used to control the final control elements lah, okay. Let's say you have a like a PID control or any of microprocessor control, it's transform the voltage to this movement of the actuator. Okay, so pneumatic signal can be used to actuate, okay, large valve, okay, and others high power control device. So the move and also move a significant loads, okay. So basically, because each of the actuator have their range and requirements. So basically, if we compare, hydraulic is more powerful lah, but because the pneumatic is use air, okay, and then the hydraulic is use oil, so that is have a transfer of more powers compared to pneumatic. But yet it's also, it still can move some kind of device, okay, to do a counter measurement, okay. Okay, so let's see some of the practical system, okay, and a real life application of the using pneumatic, okay. So basically, pneumatic is all about compressed air to do a work, okay. It's involve air elements, okay. So the compressed air is simply the air that we breathe, okay, and then it's forced into a small space so that it gets a higher pressure and it can force something to be moved, okay. So basically the pneumatic system are more common than you would think, and are used extensive in industry lah, okay. Basically, like for example, you want to move on object using conveyor, okay, or you want to hold or clamp a parts to assembly together lah, okay. This is the kind of when a system using a pneumatic in a factory, for example, okay, you have some of the boxes, okay, in the conveyor. So this is the actuator, okay, it push the when the box come to the next conveyor, okay, it push it, the box to the next conveyor, okay. So this is one kind of example in the factory system, okay. And in fact, pneumatic is used quite a lot every day lah, okay. When you drive a car, you need to pump your tire, everything is use a pneumatic system. And also when you ride a bus, okay, and you already know that when you want to going down on go into the bus, the the system of gates is using a pneumatic. There's some kind of compressed air that you alert, okay, that when you want to open the door of the bus, okay. So this is various kind type of actuators and pneumatic components that are available in the market, okay, that maybe you can search, okay, and what kind of pneumatic system that can be used, okay. And also this is the background, I mean that the unseen thing of the pneumatic system, that how it works, okay. So basically in simulation you can do all this symbol of pneumatic circuit to simulate your system, how the pneumatic actuator works, okay. Maybe you can learn after this on the more detail on the symbol of pneumatics and also the hydraulic actuator. Okay, so this is basically the setup that we have in the lab, okay, but unfortunately when this sem you need to go on the online class, so this is basically in practical you can use it to do some of your uh, group project report, but unfortunately it cannot be happen this sem due to the some COVID-19 issue. So but somehow we can do it simulation, and later on if you have a chance you can maybe you can visit the lab, automation lab, to see the setup on the pneumatic system, okay. But also you can view in the YouTube video on how the pneumatic system works, okay, practically. Okay, so this is on the hydraulic. Okay, basically it can use even the higher power control device. Okay, but more expensive. Okay, uh, than pneumatic system lah. Okay, but we must alert on the danger of the oil leaks. Okay, of this uh, hydraulic system. Okay, because when it leaks, okay, it will have a it will not function as easy lah. Okay, this is some of the example. One of them about using the excavator that's using to move the arms. Okay, using the hydraulic, a very powerful hydraulic actuator system lah. Okay. Uh, okay, let's move to the next one. Okay, this is on the hydraulic system. Okay. So this is overview on the overall system. Okay, which okay, on the overall view of the hydraulic system, okay, how it works, okay. So basically we have a sump, okay, in the system of the hydraulic system. We have sump which we fill on which is the oil, okay. So the pump, okay, the electrical motor will move the pump. So this is like a three or four various of pump, okay, including the gear, okay, the gear type pump, okay, the vane, and also the piston type pump, okay. So basically the pump will suck the oil, okay, and transfer the pressure oil to this non-return valve, okay. So basically we have a non-return valve because we want to avoid the oil to return back to the pump, okay. So then the pressure oil will be passed to this pressure relief valve, okay. So the function of this pressure relief valve is to make sure that if there any pressure that over the safety level of the requirements, it's transfer the pressure release back to the oil sump system, and it's only transfer just a requirement of the pressure oil only lah, okay. So basically before going to the system to move the actuator system, there are one subsystem that called accumulator, okay. So basically this accumulator is to smooth out any of short-term fluctuation in the output of the oil pressure lah, okay. So basically it's going is the function is very simple. It's control the oil, okay, the oil pressure lah, okay. So for example, if the oil pressure is increased, okay, the bladder here, okay, will contract and reduce the pressure lah, okay. And also the vice versa lah. If the pressure is too low, it also will move, and basically it's the hydraulic fluid pressure can be controlled lah, okay. It can release some of the kind through this gas and to this gas changing valve lah. Okay, but basically the function is very clear. It's just to control the value the volume of the oil. Okay, okay. So after that is a closed loop system, when the used oil will return to the sump and is repeat itself lah. Okay. Okay, so the next one is the first type of gear pump. Okay, the what I highlight here. Okay, the two important things in the system, which is the pump and also the accumulator. Okay, so we have various type of pump. Okay. Okay, the first one is a gear pump. Okay, you can see this is the mechanism of the gear pumps. Okay, this is a real cross-section view, okay, of the pump. So basically, the oil will be going through this inlet ports. Okay, okay, and then you have a motor that will move this gear lah. Okay, okay, so this is the 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 important part of this gear pump, which is the intermeshing gears. Okay, so the intermeshing gear will move like this, okay, in the opposite directions. So basically the fluid is trapped and it moves towards follow this movement of this gear lah. Okay, so it's going out to the outlet ports, okay, to the next level of the system lah. Okay, so this is how it works. Okay, basically, so basically the system is quite largely used because of due to the low cost and robust. Okay, and the pressure is about can be about below 15 MPa at the 2400 rotation per minute lah. Okay, so that's the general function of this pump. Okay, okay, so but this is some of the weakness of this type, where it easily can leak. This system is can easily leak due to the gear system lah. Okay, okay, the next one is on this hydraulic pumps using a vane. Okay, the vane pump. Okay, so this is the diagram. Okay, how it works. Okay, basically the oil here, okay, to go to the inlet ports, so it have a rotor, okay, inside this casing. Okay, so basically it will move like this. Okay, okay, and there's a spring loaded sliding vanes that control the movement, okay, of the oil, the trapped oil lah. Okay, so it'll be when this rotor is moved like this, so the trap fluid will follow the flow and going to the discharge port. Okay, so for this system, basically is have the advantage of is less in leaking compared to the gear pump. Okay, due to their mechanism. Okay, like this. So you can view this YouTube video on how it works. Okay, basically. Okay, so the next one is on the piston pump. So basically there will be two type of piston pumps, the radial and the axial. So this is the radial one. Okay, so for the radial piston pump, you have this rotating cylinder blocks. Okay, that will move radially. Okay, and also together there's always a inlet and outlet port where the oil is going through the inlet ports. Okay, through this movement of the rotating cylinder blocks. Okay, and it will move the oil towards the outlet ports. Okay, okay, so maybe you can see the simulations of this movement. Okay, okay, the oil going through this radial, it move in the radial lah. Okay, radial piston. Okay, it's not the axial, it's move in the rounds. Okay, in the radial, and is going to the outlet port lah. Okay, to move your actuation system. Okay, so the next one is on the axial. Okay, the axial piston pump. Okay, you have inlet ports as usual. Going to the inlet port, and this swash plate. There's a rotating shaft here connected to this swash plate. That when it's rotate, it will move this swash plate axially lah, in angle lah. Okay, but still yet this move in the axial lah, mean that this piston move in axially and the output pun move in axially lah. Okay, so basically the swash plate, which this angle is the most important characteristic of this pump, so that it can move this piston cylinder axially lah. Okay, so this is how it works. Okay, you can see the plate, okay, which this angle it can move the input oil, and it can provide the output oil here. Okay, so the next one is on the pneumatic. Okay, so basically it's have almost a similar system, but in detail is quite different lah. Okay, so basically when the input of oil of air, okay, is going to the filter system and silencer. Okay, so basically the silencer is function to reduce a noise, okay, because it involve a air. When is want to move using the air, is like have a sound like a chit chat sounds. So that's basically we have a silencer to reduce that noise, okay, because you use the air when there's any of the, I mean that inconsistency compared to oil, or because if we, let's say we have the case, okay, or the box, we can feel the oil, the liquid, mean uniformly, but in terms of gas or air is difficult, so that when there's some of the slot that cannot fill with the air, so that it will produce some noise. Okay, it's like not a fully compressed air. So from that, silencer is moved to the electric motor, will move the compressor. Okay, so the compressor, that's the different compressor that we can use. Okay, we have three type of compressor. I will show you after this. Okay, so that is send the compressed air towards the pressure relief valve. Okay, so the same function as a hydraulic system is to control the safety level of the pressure. Okay, this one control for the air, for the hydraulic is control for the oil. Okay, since it involve the air, so basically when we very high pressure air will produce a uh, increase of the temperature. Okay, so basically we must have a cooler system to for the to reduce the temperature lah. Okay, then we going to the filter, and the water tracks is the to any contaminator that have, okay, they can filter here before it send the more clean air to the your actuator system, so that it can move more uniformly lah. Okay, so basically same to the hydraulics, it have a control of the air volume also. This is called air receiver. The function is same to the accumulator, but this is to control the air pressure and volume before it sent to the to move your actuator system. Okay, so basically we have a basic form of this one is on the example of single acting single stage compressor. Okay, this is basically that what we have in our engine. Okay, the automotive engine. We the function is that the air, okay, is a only single action, because it move the air movement, okay, to inside the cylindrical, and then it compress is a one shot movement lah. Okay, so that why it's called a single acting. Okay, so basically the compressor goes, okay, from the compressed air is from the atmosphere air, okay, to the requirement pressure air in one single shot action lah. Okay, because that is another reason why it's called a single acting, because from this atmosphere air it starts to this cylinder, and then it's compressed is just in a one direction. Okay, going down and going up is a single one shots. Okay, and then also uh, because of one pulse, okay, when it's going down and then going up again is considered as a one pulse. Okay, of the air is produced per single stroke. Okay, so this a one stroke of movement is produce a one pulse. So there's another reason why it's called a single acting and single stage compressor lah. Okay, so for the double acting compressor, basically it can produce the air for the both up and down system lah. Okay, so when it require a more higher pressure bar, it have a multiple stage, okay, of movement. So this will have a called a double or multiple stage compressor lah. Okay, so basically this compressor uh, can produce of about 0.02 to 600 meter cube per minute of the flow rate, okay, of the air flow rates. Okay, and then okay, uh, when it's come to the more stage of the pressure bar, okay, let's say this is up to maybe 10 bar. Okay, let's say we consider as a 10 bar. Maybe the system need 15 bar. Okay, so this is why there is a sum of two stage of the compressor is used, okay, for the pressure bar between 10 to 5. Maybe the first stage it can only produce 10 and another stage is produce another 5, so it's a total of 15 bar for the pressure that produce to move the actuator system. Okay, so there's another term is called a rotating piston. Okay, is have a like a 12 bar in the single shots. Okay, but in the multi stage it can produce up to 140 bar. Okay, as a pressure to the actuator system. So the next one is on the rotary vane. Okay, this is a rotary vane. Basically, the concept is similar to the hydraulic one. Okay, the vane pump. Just this one is using oil. This one is using air. Okay, the function you can refer back is almost similar. And this is the screw compressor. Also the same one to the one that we have in the gear hydraulic system. This one is using the intermesh screw. Okay, when the intake port can have the air, and then it will move towards this small space as a compressed air, and it will discharge. Have a discharge port here. Is have a cylindrical drive in the rotating motions. Okay, so if we see in terms of this side of view, we can see like two gear move together like the same one as what we have in hydraulics. Okay, so basically uh, this is a three type of the compressor, okay, that we can use in this pneumatic actuator system lah. Okay, okay, the final part of the today lecture is on the valve. Okay, so basically for the both pneumatic and hydraulic system actuator, we have two types of valve, which is finite and infinite valve. Okay, so the finite valve is just to allow or block the fluid flow, such as we have a switch on or switch for the actuator lah. Okay, on the flow is we give the we allow the flow to move the actuator, and we off is block the movement lah. Okay, so basically it's allow fluid to flow from the one part to the one part of the system or one actuator to another actuator lah. That's the why we call it finite. And for the infinite is have a more advantage. It can control fluid flow anywhere between the fully on and off condition lah. Okay, any parts of the move for the movement of the actuator, it can be controlled between that. So basically it can control various force. Okay, we can verify in terms of we can make a control the various value of force and the flow rates, different flow rates for the accurate process of the control of the actuator lah. Okay, so there's a more advantage of using the infinite compared to the finite. But if you have a very simple system, you just can use a finite type of valve or the Bose actuator lah. Okay. Okay, for today that's all. Okay, we will meet again for the next lecture. Okay, thank you very much.